Good afternoon, everyone, and thank you for joining us for the Revit Pub Night. We're just going to get started in about a few seconds. We're just going to load up our presentation deck, and we'll go through a few things in the front end about an introduction, go through a couple of newsreel highlights, and then we're going to kick it off with our presenters today. My name is Dan Coogan. I'm with SolidCAD, and I thank you again for joining us. Beside me on my right is actually our marketing coordinator here, Ricky, who is going to be doing a lot of the technical handoffs here with our presentation and our speakers. So just to ensure that everything is running smoothly. I also have my co-host, Ian MacArthur, who you'll see halfway through this presentation. And let's kick it off. So Ricky, can you launch our usual PowerPoint deck? So again, thank you for joining today's Revit Pub Night, or I should call it more like the Revit Pub Day, virtual. So we are running these events usually in person, but because of COVID-19 pandemic, we're going to, in a lockdown, we're going to be running these virtually for the next while. So on our agenda today, we have Dr. Nathaniel Jones from Arup, who's going to be giving us an extraordinary presentation on some very unique things that are related to Revit and the graphics and some lighting details. And then also we'll get Peter Rezavi from Autodesk to talk about the Autodesk Construction Solutions and changes in that. At the end, we'll also be leaving the presentation open and for anyone to provide their questions. So please use the chat box to post your questions. So again, please have a drink if you have one in hand, but don't do anything careless like opening the central model. So again, I always kind of like to warm up the crowd with finding a funny meme on the internet. So this one I came across, and I just had to make sure it was kind of funny with Jay Polding, one of our lead technical and sales specialists. Again, what's the purpose of the Revit Pub Night, or Pub Day, we should call it? Again, it's to network and exchange ideas with other Revit users throughout Canada. Create discussions. It's not just focused on Revit, but the ecosystem around Revit. So we do always bring out some other products and services that are related to the Revit platform, but Revit is kind of the core theme and central idea throughout this presentation. Just a reminder, if you are, we might take a picture or so of the presentation. So if your name is on maybe a question or two, you might see it on some of our social media. And some of our social media handles, you can find us on Instagram, on LinkedIn, and Twitter. And please, if you like, you can also tag us with the virtual Revit Pub Night. So the Revit Pub Night, again, we started this a few years ago. Started with a small group of 30 to 40, and since then it's kind of grown to over 100 plus people who usually attended here in Toronto. We've actually launched it also in Vancouver just before COVID hit. Again, we're focusing on Revit as a core product that all of us use and how we're using it in different ways. So we have a lot of participants coming from different disciplines: construction, architecture, engineering, building product specialists. Everyone's got different use of Revit. So that's what's great about Revit. It's not just a product that fits only one solution, but many different industries and ways of using it. And many different users in the group, from our high-end experts down to the individuals who are just coming out of school who just recently learned it. So definitely let's help those individuals who are just coming in the industry learn Revit, understand BIM, so we can really advance our industry. So a couple of news points that we're going to go through. Just a quick reminder, if you don't know already, SolidCAD, we do have a lot of product partnerships. So definitely, have a look at our website. We just recently launched the brand new website. Our hard work from our marketing team, and definitely a lot of improvements that you'll see there. Just a quick reminder, CTC has been recently updated as well, so definitely check it out if you haven't already. Some new things that have come out with the Project Suite and BIM Manager Suite, as well as Hive. Also a reminder, we have some upcoming SolidCAD Dynamo Masterclasses. So we have 2 spots left, 1 in each. These actually sell out pretty quickly, so they are coming up relatively soon, one on February 9th, one on March 2nd. Now, if you've never taken one of these Revit Dynamo classes, the master classes, I should say, they are pretty advanced. And most of the times, the trainers that we scope for these sessions are really high-end guys. So the participants have sometimes come up pretty overwhelmed by the amount of information. So if you want to sharpen your Dynamo skills, if you think you know Dynamo, take one of these master classes to kind of up your game and learn how to further script Revit. We also have some different service bundles from some of the other products that we offer and support, such as BIM 360, CTC Hive, as well as Bluebeam. And Bluebeam, we have different modules, so definitely something, if your company is still using the traditional ways of paper markups, maybe start looking at using digital paper workflows with Bluebeam, as well as taking advantage of the collaboration features within Studio. Also a reminder under Autodesk, if you haven't realized yet, they are retiring the multi-user licenses. If you cannot purchase new ones, you cannot renew them anymore in the next couple of weeks. It is done. So what that means is that you have an old multi-user license under the AEC collection coming up for renewal, you will have one chance to convert that into a 2-to-1 single user. Okay, and you have to exercise that option at your first upcoming renewal. If you're unsure about this change, please speak with one of our customer service reps or one of your account managers, and they'll be happy to assist you with the changes in the Autodesk retirement of network licenses and the trade-in to single users. Also, something that you should be aware of, there are some new changes and improvements and things that are going to be added to the AEC collection subscribers, some access to the Autodesk Construction Cloud. There's a lot of information under that, so please, you're going to have to speak with our account managers. Also, a good thing for anyone who's working on some older projects, Autodesk is now supporting access to releases that are 6 versions back, not the 3 that were usually provided. So if you have projects still under 2014, 16, 17, you can reach out to our support team and we'll be able to get you the previous serial numbers to use for those previous versions. Also on the rise is some license compliances. So just a quick reminder, please do your due diligence and make sure you've got a proper setup in your company deployment and all your users. Keep a good track on who's got what assigned. Because again, we've seen a lot of cases recently for license compliancy. If you're not sure what you're allowed to do and what you can't do, please speak with one of our account managers and they'll be able to assist you with the proper setup. And of course, with the changes in the AEC collection, always more details with Autodesk. Also, some news from Bluebeam. Review 2020 did come out, so definitely make sure, 20.1.5 release. So definitely some new improvements and features. So definitely if you haven't upgraded your Review 2019, if you're on maintenance or earlier versions, please take a look at Review 2020 and you could reach out to our support team to help you with the upgrade to Review 2020. Also, a reminder, Matterport has been really successful in our business here, and we're seeing a lot more use of reality capture, especially as we are forced to do social distancing. So a lot of companies have started to embrace Matterport for scan to BIM and scan to CAD workflows. So if you are interested in learning about how it works, reach out to our sales team, or you can go right to our website, our e-store, and take a look at what the pricing is. But it's a very affordable platform for you to start leveraging it for scan to BIM and scan to CAD workflows. Also a reminder from our friends at Chaos Group. So there have been new releases for V-Ray. I did remind you last time, but V-Ray 5 was available now for 3ds Max users. V-Ray 3 versions and anything earlier, those have fully retired. So you cannot upgrade those versions to any of the current V-Ray 5. What you can do is you can trade in those old versions of V-Ray 3 into a master collection subscription and receive a first-year discount. So if you are interested in moving to a subscription model, or if you're interested in knowing more about the V-Ray 5, please talk to our sales team or our technical team and they'll be happy to assist you. Also to remind you that V-Ray 5 for Revit will be officially released on February 23rd. So I know that there's quite a few users out there who are still loving V-Ray for Revit. So a quick sneak peek of what's coming in. You'll definitely see some improvements on the GPU and CPU capabilities within it. Also, you'll see a lot more tweaking and pouring some of that programming improvements from V-Ray 3DS into the Revit platform, as well as some improvements to the material library, and also being able to use the V-Ray Cloud for fast tracking your rendering. So today's presentations from today's afternoon presentations, we have Dr. Nathaniel Jones, building physicist, who came to us highly recommended from our very close friend, Colin McCrone. And if you've never seen Colin speak, he overwhelmed a lot of our Revit users here in Toronto. So I think Nathaniel is going to be doing just the same, giving you something very unique that we've never seen within the Revit community. Our other presenter is going to be Peter Razavi, sorry for my mispronunciation, who's going to be talking about our Autodesk Construction Solutions and seeing what the new changes are coming from Autodesk. So without further ado, I'm going to pass the mic and the camera over to Nathaniel.
All right, thanks, Dan. I'm going to try to wind this up so I can share my screen. And there we go. Hope you can see that. So I'm going to be, I called this kind of for fun, massive parallelism, or how I learned to stop worrying and love big models. And Colin asked me a while ago if I could talk about, why it is that some software is slow and how you can make it faster. And I have a bit of background in this area. So I work at Arup. And if you're not familiar with Arup, we're a global company working in the built environment, trying to create a better world through better engineering. The picture up here is a picture of 181 Fremont Street in San Francisco, which I understand is reputed to be the most earthquake-resistant tall building in the world now. These are difficult engineering challenges that we like to face. And I have my own area that I really tend to work in, which is looking at building occupants. What makes them comfortable? How do we keep them healthy and safe inside buildings? And there are a number of factors that I look at there: daylight glare, views, wind, pollutants, smell, and now increasingly COVID. But what all these have in common is that they rely on having digital models of the built environment. So I have to admit that I'm not really a Revit user. I take a lot of models from Revit and bring them into other environments. And so that means that most of my use of Revit kind of looks like this. I can spend a lot of time waiting for these models to load. Once they load, it's just a quick export and I'm done with it. But it did bring up the question, why does it take so long to do some things in Revit? Why do we have to wait for things to load? Why do we have to wait for the view to update when you move the camera? All these questions. And we know that there are other environments where these things work very fast. So just for an example, I pulled up the VRCAD environment. It was shown off at the GPU Technology Conference hosted by NVIDIA in 2018. And the idea of this arcade is that you and a bunch of your friends are running around in this warehouse with VR goggles on. So you're seeing a simulated environment, and you and your friends are running around with guns in that environment. And of course, if you had to stop and wait for something to load, this could be a very annoying. If your whole environment just stopped and you saw a little spinny disk for a while it was loading the new scene. So why are some of these things so much faster than others? And I know that there are a number of resources that you can go to on the internet to find out how you can speed up your own Revit model and use more efficient families and so on. I'm not going to talk too much about that, except just to acknowledge that that stuff is out there. But what I did want to bring up is this question: why are some tools so much faster than others? And I have a lot of experience working with tools in the lighting area, so I thought I'd show an example from lighting. Here you have a very accurate simulation of, an environment, of the luminous environment in an office, which took about 49 minutes to run, and it's shown here in false color, so you can get a true idea of the range of light levels in that space. And next to it, A relatively fast simulation, just a couple of parameter tweaks in order to get it to run quickly, but the result of running it quickly is you get a lot less light in there. And if your goal was to try to make a decision based on that, you might see that there's not enough light, and so you go and make larger windows, which could expose you to the possibility of overheating or glare. So do we want those models to run fast? Well, here I tracked the use of one architect using a tool. In this case, it was Rhino, and looking at how often they entered commands and how many objects were affected by those commands. So the horizontal axis on this graph is showing time, and the vertical axis shows the number of objects affected by each command. And as you can see, that commands get entered very rapidly. There's very little space between one command and the next. And so if you want to run a fast simulation, there are a number of times you could enter that. But if you want to run an hour-long simulation, there's really only one time that this architect could have done that in their workflow, and that was when they took lunch. So in order to try to understand why some tools are fast and why some are slow, I decided to try to go with the cooking analogy. So the way that you were taught to program, if you took a programming course in college, was probably something like the way this chef is making, a meal, like, very carefully, one step at a time, following a recipe. And there's probably a lot of repeated actions that go on, but everything's done carefully, one step at a time. And so, for instance, in your programming class, you probably learned that if you need to do something over and over again, one step at a time, you write a for loop. And so let's say, this is just a toy example I made up. You want to take an array of a million random numbers, and add 1 to each number. You're going to end up with an array of a million numbers with one greater than the first array. And the way that works to the computer is that, it gets an instruction, add 1 to the first value, and it does that. And it says add 1 to the second value, and it does that, and so on, and so on, and so on. And the things that all those instructions can just take a while. So I want to try to contrast that to what happens on a production life. You need to make a whole lot of something at the same time. You end up with this conveyor belt and you're just mass producing it. That's a very different environment from that classic chef. And computers can do this too. So let's take that same array and let's just give it the instruction, add 1 to everything. The computer sees it like this. It gets this instruction, add 1 to this value, and all the addition registers say okay, and they do that to their value. Now we're replacing that for loop that took many steps to add 1 and replacing it with a single instruction. And that can be significantly faster. And in fact, on my computer, it turned out to be 30 times faster to do that than to do the sort of classic for loop. This is a model that we call single instruction multiple data programming, or SIMD. And I thought I'd give an example from my work. So, one of the things that I do in lighting, quite often when people want, to check off on their LEED certification that they have a daylit building, they come to me, and I, and everyone who does daylighting is essentially just running this program in some form or other. I wrote it out here just to see how it worked, and it turns out it's got 2 for loops and 3 if statements, and you run this and you can get your daylight value that tells you if you got the LEED point or not. And I thought, well, what happens if we take this and we write it with the Python NumPy library, like I showed with that earlier example that turned out to run 30 times faster. And it turns out that that whole big set of loops can condense into just 5 lines of code, where the inputs, instead of being single values, are a matrix and 2 arrays. This is a type of programming, with no loops, no if statements, and much faster. It's that SIMD programming. And I want to go, one step farther. And for this, I have to, go to a different language. This is the CUDA language, which was given to us by NVIDIA for graphics processors, which is the question of what if we don't want everything to follow the same instructions? What if your assembly line making cupcakes is putting, swirly frosting on some of them and vanilla frosting on others? Each one needs to be made somewhat different, but you still want them all to run at the same time. In this case, let's just say we want to add 1 to all of those numbers only if they're less than 0.5. So then I'm going to send out this instruction, and all of our cores are going to follow that instruction if it's applicable to them. This is another model of programming called single instruction multiple thread programming, or SIMT. And this allows us to do some very amazing things. It's specially built for GPUs. So I'm showing what I have in my computer. I've got a 4-core CPU, and I've got a 4,000 core GPU. That means it can run 4,000 separate similar processes simultaneously. You get big speedups because you're doing so much work at the same time. This is a demonstration from NVIDIA showing the effect of that, using machine learning to try to classify images. And training that on a CPU, they're they're running 4 images a second on from their training set. Running this on a GPU, they process 873 images per second. Really just amazing what the speed up that you can get there is. This allows us to do fancy rendering too. How does that rendering work? It's pretty simple. You create an image plane, and for each of those pixels in the image plane, you'll just send array through. All of those, again, using the same program. So the same set of instructions, just with different data and reacting differently to whatever they hit. So in some cases, they'll, from that hit point, they'll go and discover that they can see the light source. Other points, they see that they're in shadow, and they can also sample the diffuse light around them in order to get the full picture of what is there, and that final value that they calculate gets sent back to the image plane. That's what you end up rendering, and that can happen in a single pass. Even though each pixel is returning a different value, they're all running the same code. That's done some really amazing things. So, take this example again from NVIDIA, where they're training machine learning to understand the environment around a self-driving car. So this car has to process everything that's happening around it. Well, the scene that it's in is a simulated image. It's not actually driving anywhere. It's just seeing this, computer rendered virtual environment. It's it's using image processing to understand that virtual environment and identify the objects there, and then using that to control the car. And the car itself is also virtual in this case. So you have 3 virtual elements interacting together in real time, so the real car can someday use that information to drive itself. So all this is really amazing, but getting back to the question of designing a building, do faster tools make a difference? I mean, we know we like it when we can do things faster, but does it really help us? Does it make us design differently? I tried to answer this question with the help of at MIT, Professor Les Norford. And I bring up, his help. The one thing that he did that was really great for me is he went on sabbatical and left his office empty and unlocked. And so, what can happen, if you're a university faculty and you leave your office unlocked, is that some grad student can come in and set up a human subjects experiment in your office. And that's exactly what happened. I brought in some computers and brought in 40 students and asked them to try to solve this problem where they had a mock-up of a room, and they needed to try to design it to have a nice luminous environment. So enough light to work by and minimal glare. And there were 2 ways they could do that. One was to use a common commercial tool, in this case was Diva for Rhino, that would allow them to place a camera somewhere and run an analysis of that spot, and then move the camera and try again. It took about 20 to 30 seconds to render each scene. The other method was using this tool that I developed called Accelerate-RT. The idea here is that you can move around as if you were in a video game. It's constantly rendering the luminous environment around you, and you can use that and edit the model to add in shading devices and see if you can create something that looks like it will have a better visual environment. So adding in these blinds, changing the number of blinds in there, and then moving around to different parts of the scene to see if you can come up with something that you're happy with. And I looked at the way that people interacted with these 2 tools. So in this case, you're seeing timelines for 5 different test subjects, and each dot represents some action that that subject was taking. And what you see is there's a very different pattern with the set on top, which is for the slower tool, Diva, and on the bottom for the real-time tool. It's just a different way of working, different patterns. One is very staccato, the other is has much more sense of flow to it. So did this make a difference? Well, One thing I found is that it changed the amount of, the number of places where people actually looked. So the number of viewpoints that they chose in these models. When they had the faster tool, they examined more viewpoints. And here the darkness of each triangle represents the amount of time cumulatively that all the subjects spent looking at those viewpoints. It also changed their self-assessment of how well they did. So the participants who used the faster tool were more confident in their assessment of glare and more confident in the final design that they chose. They were still, found the, DIVA to be more familiar. DIVA is the commercial tool. In fact, only 18% of them found Accelerad to be more familiar, which is kind of amazing when you think about it, because none of them had used Accelerad before. So they were more confident about their designs. But were they right? Did they actually choose designs that performed better in terms of giving more light with less glare? Well, in order to answer this, I had to look at all of the possible designs that they could have chosen and how much glare there was in each of those locations. So that's 800 locations with 8 viewing directions, let's say, and 2,000 hours during the year when that space is occupied, and 400 and some different facade options that they could have chosen. And if I want to render each of those to analyze how much glare there is, I need to look at 6 billion images. So how long does it take to run an analysis of 6 billion images? Well, if I want to render them all out, it's going to take me 250,000 years, which is a little bit more time than I want to spend. It turns out there are a number of faster ways that I can do this. Again, same problem, coming up with the same answer, but using different methods. And even using a CPU with some very efficient techniques, I can get it down to about 8 days. If I run that same thing using SIMD programming on a GPU, I can take it down to 2Ds. That's using the CUDA language. And now with modern GPUs that have built-in ray tracing cores, that's down to 14 hours, potentially less with today's new GPUs. So when you think about it, this is getting 156 million times faster, getting the same result just by changing the process, changing the way that I've programmed this result. So here I plotted out for each of the 2 scenes that the students looked at, how many, each little dot represents one option they could have chosen, with the horizontal axis being how well daylit the space is and the vertical axis being how much glare there is. Obviously, you want to be in the lower right corner, so you want a lot of daylight and very little glare. And there's no perfect option, but there are a lot of options that are, sort of close to perfect. They're what we call the Pareto Frontier, which is, this lower curve here on each of those. And it turns out that in all, about 60% of the students picked Pareto optimal designs when they were using the faster tool. Only 40% of them picked Pareto optimal designs using the slower tool. So that's a significant difference made by having the faster tool available. And in case you're interested, here are the 2 designs that were chosen the most frequently, and they are both Pareto optimal designs. So why? What was going on in their thought processes? Why did they come up with better designs using a faster tool? One possibility is maybe just looking at more options helped them come up with faster designs. Well, it turns out that's not really the case. If you consider the students who came up with Pareto optimal designs and the ones who did not, if anything, the students who did not come up with optimal designs looked at slightly more design options than the ones who did come up with optimal designs. So you can't just explain it away by saying they looked at more options and found better options as a result. Some of the things that did matter, one was background. The students with architectural backgrounds were much more likely than the ones with non-architectural backgrounds to come up with optimal designs, but only if they had the faster tool. If they were using the slower tool, then it made no difference. Also, those students who had had 3 or more years of professional experience before going back to school were much more likely to come up with an optimal design than students who didn't have that background. But again, only if they were using the faster tool. So what's going on here? Well, the theory that I have is that you need a combination of a fast answer to your question and the knowledge of how to ask that question in order to come up with a good design. What the tool is doing is it's giving you the fast answer, but it's not replacing the experience that you already have. I want to try to explain this using this idea of the unified theory of cognition, which is this theory developed by Alan Newell that classified different interactions that we have with digital tools in terms of how we perform that interaction, and in part, how long it takes to do that action. So we have deliberate acts like clicking a mouse, typing a key that we do essentially without thinking. They take almost no time. Our brain doesn't really process them. And at the other extreme, we have unit tasks. These are things like modeling, writing, playing games, things that involve strategy, where we take the time to think about each action before we do it. And somewhere in the middle, we have cognitive operations. These are things like typing in a command, running a web search, something that we don't need to think very much about. It takes pretty minimal thought, but it does take some thought. And the idea that I want to pose is that even though each of these is a mode of thinking, which takes a different amount of time for our brain to process, we can take some type of action and switch it between each of these modes depending on how long the action takes for the computer to run. So when we look at that original graph that I showed, looking at the patterns of activity for the same subjects when they were using a slow tool and a fast tool, and you see how there is that staccato pattern for one and the flowing pattern for another, what you're seeing there is a different type of thought in action. Now, the tool has come a long way since then. That study was done in 2016. Over the last couple of years, the tool has become much more fancy. It's gotten a lot more widgets in it, but it still operates under that basic idea that you have this environment that you can move around quickly. Even this model with 1 billion polygons in it, something that takes a bit of time to render. Yes, it is a bit jerky, but this is still real-time interaction. And by offering real-time interaction, where you can move through a model and get live updates as to what the conditions of the model are, you're able to make better decisions. And that's really the advantage that I want to show off with fast tools and why we should all work to build fast tools. All right, thanks, Dan. I guess I can turn this back over to you.
Thanks, Nathaniel. So I definitely have quite a few questions I'm going to ask you later. We're going to take a quick break. We're going to come back online at 4 o'clock with our next presenter. I did make a mistake earlier in my presentation. Our presenter is actually going to be David Nichols. So he will be on the next presentation. Okay, so stay tuned and we'll be back at 4 o'clock.
Hey everybody, welcome back to the second session of our Revit Afternoon Pub Night. My name is Ian MacArthur. I'm one of the account managers here at SolidCAD out of the Toronto office. And with me today is David Nichols from Autodesk. He's a part of the Autodesk Construction Services team. To give it a little bit of intro before I completely hand it over to David, some of you may be aware that sort of late last year, an announcement went out from Autodesk about what they're calling connected construction and a new unified platform. They've made a fair amount of investments over the last few years, acquired a fair number of companies like PlanGrid, Assemble Systems, and what David's going to show off is sort of the future of what that looks like, trying to bring everything together into a unified platform. So with that said, let me spotlight you here.
So hi, everyone. Welcome to today's webinar on connected construction. It's brought to you by yours truly, David Nichols. I'm a technical sales specialist here at Autodesk. A little bit about myself is that I do come from a construction background, used to work with a large GC up here in Canada, spent some time on the field, spent some time in the office before making the switch over to construction technology, and that's really where I am today. So today we have some really exciting things to talk about. Really, what Autodesk has really been working on in the past bit here. And before I get into too much details, I do need to share this post because right here, oh, sorry about that. There you go. So right here, I'm going to be talking about some forward-looking statements. I'm going to be talking to you about what we've been doing lately here at Autodesk. And with that being mentioned, there's nothing essentially official just out yet. There's no unified platform that's available today. However, we are really on the pinnacle, if you will, of release with a lot of great things in the pipeline as well. So I'm going to do my best and be as honest as I can to share that information. But of course, I do have to let you know that the platform's not available today, so there is still subject to change on what I'm going to present to you today. So very important to note that things might be added, things might be removed, things might be altered, all things way above my pay grade. So I'm going to share with you what we have here so far. Now, with that being mentioned, I want to talk a bit about Autodesk. Here at Autodesk, we've made significant investments, as Ian mentioned, roughly of $1.5 billion to bring together the best in breed of construction solutions such as Assemble, PlanGrid, Building Connected, and now Pipe to supplement the already powerful workflow that BIM 360 had. And with these acquisitions, we formed a new department called the Autodesk Construction Solution, where I'm part of, where our mission and vision is to essentially connect data throughout the entire project lifecycle. And I mean the entire project lifecycle, from design to planning to pre-construction to construction, of course, all the way to turnover and operations. And we're moving toward fulfilling this vision of a holistic view of the entire project by helping our users and the industry to first digitize their manual processes to capture more critical information. Now, once they digitize, from there, we want to help our users integrate their business processes and automate those manual workflows. This will break down the data silos and help data communicate between the various systems, and our users will be able to connect that data and make decisions more effectively throughout the project lifecycle. And only then, only after we digitize and we integrate, that we could actually talk about optimize stage, and where we can automate and extract powerful insights to predict a wide range of issues and risks before they happen, so we can deliver on projects more profitably, safely, and of course on time. And now our solution that enables the end-to-end connection that we talk about to help companies move through the digitize to the integrate to the optimize stages is the Autodesk Construction Cloud. Now, this is a slide that should be familiar to most people, but I do want to talk about what we're doing here at the Autodesk Construction Cloud. And as I mentioned, we are going to be addressing all those workflows, all the way from design to operation, as you can see with the granular capabilities here in this slide. We're also building all these workflows on a common data environment, which allows users to store all project information in one centralized location from the whole duration of the project. We also have all this information housed on a predictive insights and analytics layer to help you benchmark and mitigate mitigation strategies. And for you to see at the bottom layer over here, we also make it easy for our customers to use our builders network to take advantage of that large resource and find the right partners for the right jobs to collaborate on the projects they need to. Now, to deliver on this vision, in the past, we have shared our three-pronged development strategies, and I'm going to reiterate those. The first, to continue to invest in all our products in our product portfolio. Second, to build meaningful integrations between those products so that they could carry an end-to-end workflow across your project lifecycle. And then, of course, the third, which is what we're here really today to talk about, is to unify these products into a cohesive platform so that you can get the full benefits of that $1.5 billion investment that we've made over the past 2 years right out of the box. And today, I'm really happy to say we've made incredible progress in these three areas. Over the last 9 months, we have increased our development momentum and added over something like 250 new features and enhancements across BIM 360, PlanGrid, BC, and of course, Assemble. Things like assets in BIM 360, 2D takeoffs in Building Connected, and pay apps in our cost module of BIM 360. We also have, through ACC Connect and direct API integrations, completed most of our integrations between these products. We now have something over 20 or so integrations between our portfolios to help those workflows seamlessly communicate with each other. And in parallel, we have also been working hard at fulfilling the promise of true unification, where all the products come together under a single login and a single unified user experience. We've made huge strides on this third pillar. And today, I'd like to share with you a glimpse of what that progress looks like and how we're moving towards building that unified solution. When we complete our unification exercise, there will be one comprehensive web application and mobile application with a single module for each major capability. For example, there will be a single administrator module that allows you to manage projects, user provisional, entitlements, licensing. There will be a single reporting and dashboard module that gives you access to data across all capabilities in one centralized location. A single module where you can perform document management and distribute documents for every downstream activity like quantification, bidding, design, collaboration, model coordination, and field execution. There will be a single module that allows you to perform project management tasks and field collaborative activities. The single module where you can perform your project management and field collaboration, and it is called Autodesk Build. The single module where you can perform quantification is called Autodesk Takeoff, and so forth. For the first phase of unification, we will be focusing on the modules that we highlighted here. BIM Collaborate for design collaboration and model coordination, Autodesk Takeoff for 2D and 3D quantification workflows, and Autodesk Build and Cost for project and field management capabilities. As you can see in the bottom of this slide here, we have an administrative layer as well. So that's what we're going to be talking about. It has going to have Autodesk Insights for predictive analytics and insights. And of course, Autodesk Docs, which is going to be our center source of truth, our common data environment throughout the entire project lifecycle for all documentation. But before we get into the Autodesk Build capabilities, I want to take a minute to talk about the unified structure. On the left of what you see on the slide here, we have a simplified view of how teams communicate typically, how team members typically exchange information on a project. We know many of you deal with this reality today. On the right, however, we have the common data environment. The information flows from a central repository where ideally it is more easily controlled up to date. The CDE, or common data environment, also enables better transparency between all project stakeholders and helps team members access project lifecycle documents all in one centralized location. Autodesk Build is a single module within the unified solution that supports document management workflows like versioning and approvals, project management workflows like RFIs, submittals, meeting minutes, quality management workflows such as punch list, issues, and tasks, safety management workflows like safety observations, safety inspections, and of course, turnover workflows like commissioning and as-builds. It is also working closely with other modules like Autodesk Cost to complete the cost management workflows. A workflow such as an issue is brought up on site, amplified to an RFI, to a change order, and for all that information to connect between the different modules. So let's dig into these modules then. Let's first talk about streamlined document management, the foundation of any project. This is where the project stakeholders have the ability to store all project lifecycle documentation, whether it's on a basis of design, technical performance criteria, as-builds, and provide granular levels of permissioning to other team members to view and use these documents. From there, team members can also view project drawings, whether it's DDs or construction documents, and overlay the drawings, automatically identifying changes between the different iterations of design or construction documents. From there, all the project drawings or models can be sent through an approval process, whether it's a single step or multi-step, linear or parallel approval process to make sure that all key stakeholders on the project are collaborating effectively. Moving over to the project management, I want to take a look at what capabilities are within the Autodesk Build. First, we're going to talk about the ability to manage and oversee all project RFIs. This is where users have the ability to configure the RFI processes depending on how many reviewers or who needs to be part of the process. Of course, connect your RFIs like never before with project issues, potential change orders, even meeting conversations can be tied directly back to that RFI. Streamline the submittal workflow directly within Autodesk Build tool. Organize different items into packages, assign those out responsibly, and create reported reminders on a sequential, templated basis. Leverage meeting minutes to structure effective and accountable meeting conversations by tying in due dates, assignees, reference documentation such as RFIs, issues, files, sheets, all under that same application. Structure daily reports like never before. Standardize and templatize reports for easy access in the field. Capture more information with an easy-to-use template builder or leverage fillable PDFs. This one is particularly exciting for me, especially coming from a field engineer recovery. Track progress directly on the drawing set based on categorical properties. Leverage these statuses to get a holistic view of the project development. Let me give you an example that's particularly exciting for me, is I want to know how much of our overall steel actually arrived on site. How much has been installed? How much has been QA, QC? How much is actually signed off and ready to go? This is where I see this coming into play. And then, of course, track these progress tracking, these stats, if you will, directly in live dashboards. So you get a good holistic view. You get granular directly on the drawing, but also step back and see an overarching view of your progress tracking on your project. Autodesk Cost also allows the seamless communication between those project management tools we viewed previously and tying that back into the most important thing, dollar amounts. Create and import budgets, contracts directly within the platform here to manage and organize. Utilize, track, and manage the change order process, which could tie directly back into the project management tool and document management tool. Have those hyperlinked information so that it's not so distant as compared to something like an Excel file where it's handled in the middle, but no connection to either direction. This one's going to bring those pieces of the puzzle together. Utilize budget and cost payment applications to track pending and completed payments based on schedule values. Extremely exciting stuff. And then, of course, a single source of truth for all cost information. Pull cost activities into budgets, forecast, visualize budgets and cost variance, generate reports based on your budget, your cost, and have that capability directly within the same platform. Now, going back to my field engineers days, quality management. I want to take a moment here to speak about how Autodesk can really help you with your quality management, and that's via quality planning, quality control, issue management, and punch listing. So first, we're going to create and distribute quality checklists and forms directly for field engagement so they can have the capability of having and filling out these documentations directly in the field in an easy-to-use medium, being the key word there. On their mobile device, these reports can be accessed, viewed, filled out. Think of the engagement you might get from quality documents, inspection forms, NCRs, just to name a few, by giving the tools directly within the worker's hands. Autodesk has the industry-leading issue management software to streamline anything that goes wrong on the site. The tool could be used to link inspectors to work that needs to be completed, safety folks to safety hazard, even punch list the drawing location. An extremely powerful tool to ensure accountability. It can be used to promote safety and quality culture, and also be able to capture rich information coming in from the field. Information such as lessons learned, priority list, anything of the sort. All project issues from any phase of construction assembled in one centralized location. We're talking the same terminology here. Issues could span from every phase of construction. Bringing it under that one keyword allows you to filter, allows you for transparency, allows you to generate reports, promote quality and safety culture, and of course, plan work accordingly. And then, of course, the last thing we're going to talk about on Autodesk Build is likely the last step in the construction process, project closeout and commissioning. Track individual assets throughout the construction process. Track issues related to those assets. Care and preservation checklists associated to the same assets and status them. With the barcode and QR code capability, go on the field, pull out your mobile phone, scan for these assets directly on site, create issues, fill out reports, add photos, review warranty information, all through the same mobile application. You're taking advantage for that project management tools. For the document turnover, it's never been easier. Since you collected all your project data within the foundation, that document management module, simply download everything required and package it off. So let's take a moment here to acknowledge two other tools which are going to be assembled in the unified platform. Autodesk BIM Collaborate and Autodesk Takeoff. So let's start over here with the Autodesk BIM Collaborate, the design collaboration. So with that, you're going to have the capability of doing constructability reviews, change visualization, collaborate on 2D, the civil 2Ds, plant 3D, Revit collaboration directly within the platform. And BIM Collaborate also includes the model coordination portion. A good saying I remember always from the field is for every $1 you spend in model coordination, You save 10 in the shop and 100 in the field. So BIM Collaborate will allow you to automate the clash detection process by leveraging that one center source of truth, that common data environment mentioned earlier. Pull models directly in from that center source of truth and let the system automatically do the clash detection. From there, once those clashes are determined, our industry-leading issue management platform, the very same that I mentioned in Build that can be used to leverage communication for issues on site, could also communicate clashes to resolve, assign accountability, due dates, capture lessons learned, stay on top of the clash detection process by being proactive and eliminating the VDC bottleneck. So let's dive a bit into Autodesk Takeoff here and show you some of the really interesting things we're doing on this end here. So not only is it a 2D does it have 2D quantification capabilities, it's also going to have 3D capabilities. The new Autodesk Takeoff module will allow your various team members, whether it's estimators or pre-con managers, minimize the tech stack required for pre-construction workflows. Your team will have the ability to access all project documentation from that one center source of truth. From there, it could be used to complete their quantity takeoffs, push this information downstream to the construction workflow. As you can see on the slide here, users will have the flexibility between different measurement systems. They could, different classifications, master class, master format. You can even have your own custom classification inbuilt into the platform or brought into the platform and leverage on the module, the models that you're working with. Now that you can see this slide over here, your teams can also create takeoff packages and easily access all relevant documentation they need to complete their takeoffs. They can easily search for these documents, sort them in a way that makes most sense for them, and bookmark the sheets they utilize frequently. From there, the team can start creating their own takeoff items, different areas, different volume formulas, and for whatever they need, and the system will automatically tally up everything that you need for that holistic view on that takeoff package within our inventory. Your users can also dive into the 3D models for the workflow. They can view section cuts and take a look at the model properties. From there, they can easily create their takeoff items and visually track their quantification by the colorization scheme that you see over here. And lastly, all this information rolls up into an inventory where users can filter the information by different groupings, take a look at the quantities in a more granular way, and from there, connect the information off to their estimating solution. So we got all this rich data under one umbrella. What do we do with it? How can we leverage the data we just collected through the entire project lifecycle? Well, that's going to tie us back into insights here. We start off with a robust reporting capabilities, which can be scheduled and shared on a timely basis. Filter information regarding RFIs, submittals, cost, etc., to a scheduled time and let loose. Great example of this would be like a GC leveraging these automated scheduled reports to create a report every Monday morning of open and outstanding RFIs that are yet to be answered and sending that off to the architect, just to name a few. User-friendly dashboards to clarify work that needs to be done on an assignee level or a project level. That can be a great way to ensure nothing is forgotten and, of course, nothing is swept under the rug. And, of course, Construction IQ. Leverage the machine learning behind the platform to scan project data to identify risk area, risk associated with design, quality, safety, project controls. Nip these trends before they become costly or detrimental mistakes. And of course, Construction IQ spreads from individual project levels all the way to the project portfolio. Quickly identify this information, leveraging that rich information hosted within the platform. And now, I do want to show you a couple of slides from the Autodesk Insight side here. And as you can see from the images on your screen, your project team and executives can have access to native portfolio level dashboards that you can use to analyze risk associated to a project throughout the different region. Now, I'm not here to tell you Autodesk is going to be the end all be all. We're not going to be your site cams. We're not going to be the development. Maybe we won't be able to develop that dashboard that you absolutely love on Power BI. We might not be even your resource management platform. But what we could do is partner with the industry-leading solutions to natively bring you that information directly to insights. And with that mentioned, finally, the need to store documentation locally is an absolute necessity. Data Connector can help extract templatized data locally. I want to leave you with this next slide here, but this is just to show you the breadth of our partner ecosystem. You might not be utilizing all the tools you see here on the platform, but basically Autodesk has been working with these partners. We have the ability to plug these in tools to create meaningful integration and eliminate a lot of that double entry and data silos that currently exist in the industry. And with that, I'd like to thank you for your time.